If you're trying to build AI for doctors, you got to check out this paper. Hey everyone, I'm Sehj, and this is another episode of Paper Pushers. I'm covering healthcare AI papers that excite me enough to create a video about them. For those of you who don't know me, I've been in healthcare as a medical student, a data scientist, and a startup operator for 10 years. Today, I'm talking about a paper out of my former grad school lab at Stanford. It shows how well AI models like ChatGPT could assist doctors in their everyday tasks. It's an important paper to know because it open sources a very useful training data set. Plus, it shows the real-world needs of doctors from AI assistants and the performance of the current state-of-the-art assistants. Let's get into it. First, to test how well models like ChatGPT could be delegated tasks, the researchers had to create a dataset of example tasks. They circulated a very simple form to doctors at Stanford, asking them to imagine a perfect AI assistant. The doctors could write any task to this assistant that would make their jobs easier, faster, and less stressful. The researchers collected over 1,300 instructions from 15 doctors and 7 specialists, and they're in the process of actually open sourcing these. They then selected a subset of these instructions, which were general, and found a patient health record to which they could apply. So this is an example of an instruction with a matched health record. The instruction here is summarize from the EHR the strokes that the patient has had and their associated neurological deficits. And what follows after that instruction is an entire health record, sorted by most recent first to oldest at the last. You see that they've included the visit type, the details, the vitals, the labs, the meds, the results, etc. So these are instructions along with matched health records in their complete de-identified self. The matching that they did was using an automated method, which yielded about 300 instructions and a relevant matched patient health record. For these instructions, they asked clinicians to write a reference answer after reviewing the health record. The clinicians then saw and rated the results of various models like ChatGPT following the same instruction on the same health record. They judged whether the response was correct or incorrect using the following criteria. If the response had anything that was not clinically appropriate based on the available electronic health record. If the response included errors that, if corrected, would change the interpretation. Or if the response just did not address the instructions. Using this, the results that they found were illuminating. Firstly, the dataset of instructions. It's easy to think that doctors simply want assistance in note-taking or diagnosis support, but that's just a tiny sliver. Look at the tasks that doctors wanted to delegate, which have been split by the researchers into 6 major categories and multiple subcategories. The first category was information retrieval. Doctors wanted tasks like retrieving the appointment information, the genetic and family history, demographics, provider referrals, communications with the patient. So for example, doctors wanted to know how long has this patient been in the hospital this day, list all the providers who have been involved in the patient's care, who referred the patient, what is the phone number of the patient's emergency contact, summarize all the blood work that the patient has had in the past year, create patient instructions that summarize all the patient's medications. When did this patient receive his last CT scan? Well, a lot of this information is very routine and everyday for doctors who are using electronic health records, but it's tedious and it's mundane. So you're not surprised when they want to delegate these tasks to an assistant that can read the patient's health record and start answering. Another example of category of tasks was care planning. Are there any additional vaccines recommended for this patient? Create an asthma plan that's personalized to this patient. They wanted help calculating and scoring. For example, what is the patient's ASCVD risk score? How likely is this patient to develop a stroke in the next 7 days? They wanted translation help. I have a patient that speaks only French. Can you translate these PET exam instructions for preparation or diagnosis support? Based on the information about the provider, what is a reasonable differential diagnosis? When they fed these instructions to the models, the results of how well they completed these tasks were really interesting. The best model, a variation of GPT-4 that could see the whole patient record, was wrong over 34% of the time. The open source models, which they tested because they were less compute heavy and more modifiable, completed the task wrongly over 68% of the time. Imagine delegating patient care tasks to an assistant that is wrong 1/3 of the time or 2/3 of the time. The paper has a ton of deeper analysis, which I won't get into. For example, they tested whether letting the model read the whole record improved its correctness. It did at times. They tested whether one model was uniformly better than the rest, it wasn't. And finally, they looked at how the model responses compared to the doctor reference answers and which was most similar. I encourage you to read this paper if you're a doctor who's interested in steering the development of AI or an AI builder that's chasing value. This paper excited me for several reasons and made me think of a few things that I want to share. First, have a real-world dataset that has been open sourced. It includes entire patient health records that have been de-identified and clinician tasks which are relevant to those health records. The dataset is invaluable for anyone trying to align AI models for clinical usefulness. Plus, the methods that they use to make this dataset are pretty replicable. Others can make even more diverse and larger datasets. In fact, the researchers published their own app in which you can go and contribute instructions that you would delegate to an AI assistant. The second thing is, there's clearly a huge need for improving these models on clinical tasks. We'll need more such alignment datasets, and I would encourage people from different clinical fields and geographies to create such datasets and open source them. Third, there's obviously huge opportunities for AI assistants to go beyond note-taking and diagnosis support. Doctors would delegate a huge variety of tasks to AI if they could. It's now up to builders to create models that could complete these tasks very well. And lastly, I think the ultimate AI assistant will be like a universal collaborator that has a hidden team of experts. What I mean by that is doctors most probably just want to talk to one AI model to do all their different tasks. It'll be up to this model to collaborate with other specialized models to complete a task. I'm imagining models that are interoperable, work with one another, but maybe come from different companies. I'd love to hear your thoughts and reactions to this video. If you're a clinician, how do these instructions seem to you? Would you have an entirely different set of tasks to delegate? And if you're a healthcare AI builder, have you gotten over this performance challenge? And if so, how? That's all I've got for now. Leave your comments and your questions, and I hope you find this video useful. Thanks so much.